for the first question, example 1, oppositely charged parallel plates are separated by 5.33 millimeter. That is our D, distance between the two plates given. Okay, next, a potential difference of 600 volts exists between the plates. So that is our delta V difference, difference potential that's given. So we move on to first question A. What is the magnitude of the electric field between the plates? So this question is very direct. So we can just put into the equation because the question asks for magnitude. So the value must be positive because magnitude cannot be negative, as we standard physics student must know. So E equal to delta V over D. So both of the value that already been given from the question above. So directly transfer the value into the equation, the formula. So we will get 600 volt or joule over coulomb divide by 5.33. Don't forget to change to the SI unit meter. So times 10 power of -3, we get the answer 1.13 times 10 power of 5 M over coulomb. So for the B question, what is the magnitude force of an electron between the plates? So the question asks about electron. So as we know, the constant of electron is 1.6 times 10 power of -19 coulomb. So this equation F equal to QE from chapter before. So we can apply this equation into this question. F equal to QE. So E, the value that we calculate in question A, we can transfer into the this question. So we'll get the direct answer 1.8 times 10 power of -14 N Newton. So for this last question, C, how much work must be done on the electron to move in the negative plate if it's initially positioned 2.60 millimeter from the positive plate. Work equation formula, work equal to force times S cos theta. So the S, the distance we minus because initially at 2.9, not 0. So 5.33 minus 2 times F that we calculate before, cos 0, and we get the answer 4.37 times 10 power of -17 joule. That's all from me. I pass to Brother Muaz.
Right, thank you to Brother Raif. So now I'm going to proceed the presentation with the second example of question, and basically my question is related to the total electric potential. So we go through the question first, and the question said two charge which is Q1 equal to -20 nanocoulomb and Q2 is 25 nanocoulomb separated by a distance D equal to 1.5 centimeter as shown in the figure. So we can look into the figure to enhance our understanding from the question. And the question is asked about the electric potential in QV at point A. So we use the formula of electric potential, which is K and in bracket Q over R. And since there are two charges, so we have to add up V1 plus V2. And as shown in the solution at the right side, we get the formula as K in bracket Q1 over R1 plus Q2 over R2 and close bracket. So since we have already wrote the full formula, and now we just substitute the value into the formula, and we know K is constant, which is 9 times 10 to the power of 9, and in bracket Q1, which is -20 times 10 to the power of -9 over 0.015, because we have to change the centimeter unit into the meter, and plus 25 times 10 to the power of -9 over 0.015. And we calculate, we will get 3.06 kV. And for the next question, which is question B, and it asks about the electric potential in QV at point B, which is halfway between the charge. So based on the figure, we can see that point B is between the Q1 and Q2. So to find the electric potential at point B, we just use the same concept, but change the distance into 0.0075. Why? Because it is basically halfway, so it is in the middle. So we just divide the value 0.015 divide by 2, so we get the new distance for point B, and we do the same process, put it into the formula, and we calculate. So the last answer we'll get is 5.94 kV. So that's I think that's all for my part, and I pass to Brother Farhin.
So for my question, okay, let's go through the question. A particle with a charge of Q equal to 10.0 microcoulomb travels from the origin to the point XY equal to 20.0 cm, 50.0 cm in the presence of a uniform electric field E equal to 200 I volt per meter. Determine the following. So let's go through the A first. So question A, determine the change in the electric potential energy in joule of the particle field system. So to find the potential energy, we know that potential energy is equal to charge times electric potential. So the charge is given in the question, which is 10 microcoulomb, and since the particle travels from the origin to the point X, Y with the in the presence of a uniform electric field 200 I, so the delta V is equal to negative E times delta X. So we just put the value inside the equation, then we will get the answer for A. We will get the potential energy, which is negative 4 times 10 to the power of negative 4 joule. So that's for question A. Okay, let's move on to question B. Determine the electric potential difference in volt through which the particles move. So this question is easy too. So since we know that delta U is equal to Q times delta V. So we know that delta V is equal to delta U over Q. So potential difference equal to potential energy over charge. So we put the potential energy from question A to the equation, and the value of charge is given in the question. So it is negative 4 times 10 to the power of negative 4 divided by 10 times to the power of 10 times 10 to the power of negative 6. So we will calculate, put in the calculator, and then we will get the answer, which is negative 40 volt. As simple as that. Next, I pass to Brother Imran to continue our presentation. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And now I will start presenting my part. My name is Muhammad Ibrahim bin Salaman Ali Rizal. My magic number is 212052. Now I will present a question from tutorial. Question is, two small charged objects are located on the y-axis. One is at y equal to 1 meter. The other is at y equal to negative 1.00 meter. And they both have charge of q equals to positive 2.20 microcoulomb. The first question A, determine the electric potential in kilovolt on the x-axis at x equal to 0.530 meter. Okay, so the basic equation is V is equal to A Q over R plus Q over R. But we need to find the R, the radius between the two charges, which we had to use we need to find the hypotenuse. So we substitute the value given into the equation, and we will get the square root of 1 square plus 0.53 square is equal to 1.13 meter. Then that is our radius. So substitute the R into the equation that I stated earlier. V is equal to K, then both are the same, as well as the charges. K, the constant, substitute also, and we will get the answer is 35 kilovolt. B, calculate the charge and electric potential energy of the system in joule as a third charge of object of negative 3.10 microcoulomb is both from infinitely far away to a position on the x-axis at x equal to 0.530 meter. Using the formula potential energy, the change of potential energy U, delta U is equal to Q delta V. We just need to substitute all the value into the equation. First one, the charges, the charge is negative 3.0 to the power of negative 6. Then delta V is the V that we get earlier in the equation. That is 35,000, roughly 35,000 and 44 minus 0 because infinitely far away. Then that is we assume it is 0. Then calculate, we will get negative 0.1086 joule. That's all from me and my team. Thank you and Assalamualaikum warahmatullahi wabarakatuh.